start on page 5. And on page 5, you're going to have free body diagrams that are a mixture of these 4. Okay. So looking down at the first. Okay, so we have a cat with a remote control on top of their head, and we are given Newton's values for each of the remote and for the cat. Okay, so I'm going to start with the remote because the object on top is always the easiest object to draw a free body diagram for. Because remember, if an object is on top, you draw the free body diagram just like if it was an object on the ground. Okay, so it's going to look exactly like the free body diagram that I drew for number 3. Okay, so just to kind of redraw this down here. So I have my, shapes, box. So I'm going to draw a box. I'm just going to go ahead and draw boxes for each of these. Okay. And then I'm going to draw some lines. Okay, so for the remote, again, if you have an object that is in the top of the pile, that free body diagram is exactly the same as if it was just sitting on the ground. Okay, so I'm going to give it, so it has a ground surface. And the remote is on planet Earth. So we have gravity force. The remote is resting on the cat. So we have normal force. The remote is not moving, so that's why these 2 arrows should be about the same length. Whoops. That should not say gravity force, that should say normal force. Okay. For the next one, for the cat. So the cat is on planet Earth. Okay, so we're going to draw a gravity force for the cat. However, the cat also has the remote sitting on top of their head. So that means that, oops, undo that. So that means that we need to draw a push force. And we actually have numbers, so we can fill in all of these numbers. Okay. So for the remote, we know that the remote weighs 2 newtons. So that means that we have -2 newtons pushing down and +2 newtons. Oops, I messed that up. Hold on. Oops. Undo. Okay. So this would be just 2n. Okay. So for this next one, we have a gravity force of the cat. The cat weighs 45 newtons. So the gravity force is -45. The push force is coming from the remote, which weighs 2 newtons. So that is -2 newtons for the push force. And for the normal force, we want to make it taller. So Fn. Any thoughts on what Fn is going to be for this one? So we're in the same place. We have 45 and negative 45, -2 pushing down. Correct. It's going to be 47 newtons, okay? And I just kind of want to go over this for just half a second because I know I just kind of started putting numbers in and I didn't talk much about it. If you ever have values that are going down, if you ever have forces that are going down, those forces are always negative. Okay, so downward forces are always negative. So I just want to kind of put that here. Downward force always negative. Okay. There's also if you have a left and a right force, if right is positive, left is negative. Okay. For example, there are a couple of different ways that you decide which is negative, which is positive, but downward force is always, always, always negative. Oops, and I forgot to draw a line for the surface that this is resting on. Okay, just to show that. Okay, so for this next one, so we start off with the object on top, which is this hat. The hat weighs 1 Newton. Okay, so the hat is resting on a surface. Okay, so again, we go through our questions. Is the hat on planet Earth? Yes. So it has a gravity force. The hat weighs 1 Newton. So Fg equals -1 Newton. The normal force is pointing up, so Fn equals 1 Newton. And the rest of these two will continue in that same pattern where we have two forces going down, so a push and a pull and a gravity going down, and normal force going up. Okay, so I'm going to start drawing, I'm going to just start drawing in my arrows. Okay, so the person is sitting on a couch. And the person has gravity force. And they also have push force. Because they have the hat pushing down upon them. And then they also have normal force. And then normal force needs to try to be like equal to both of these. I kind of set myself up in a bad situation by making 1 Newton so long. But so Fn is equal to, so the person is 550, then plus 1, so this is 551 newtons. My gravity force just takes into consideration how much the one person weighs. Okay, so gravity force is just negative 550 newtons. Okay. And then my push force -1 newtons. Okay, so then I next have the couch. So the couch is also sitting on a surface. So I'm going to give it its surface. And whoops, that's black, but it's okay. And the couch weighs 700 newtons. So I'm going to make this arrow very long. And then it also has a push force, which is also going down, which we're going to talk about. And then a normal force, which is pointing up. Okay, so let's start with gravity force. So Fg is equal to, this is always the mass of the person, okay? So this is just going to be negative 700 newtons because the couch weighs 700, okay? The push force feel like it's starting to get a little messy with the pen, so hold on a second. FP equals 551 newtons. Oops. Negative. I keep doing that. Okay. Then the force normal is going to equal the sum of those two at the bottom. So 700 plus 551, 1351 newtons. Are we starting to see the pattern here?